Saxon Algebra 1/2, lesson 76, multiplying with scientific notation. All right, we've talked about scientific notation. I told you that it's super useful for taking either really big numbers or really little numbers and putting them into a code that makes them much easier to manage. We've learned a little bit about how to put the numbers into the code. And now we're going to practice taking numbers that are already in the code format and multiplying them. I don't think we're doing any division. No, we're just going to do 3 multiplications and then you'll get a turn to do it yourself. Oh, I'm so excited for you. It's going to be really fun. You guys, this will make you feel smart because it looks really hard, but it's not that bad. 4 times 10 to the 5th. And John puts a big fat multiplication sign in between. This x is not an x like x equals. This is multiplying. And then, okay, we're going to do this multiplication. This is a big number. This is a small number. You can tell because this has positive exponent, that has negative exponent. This tells me that when we put it back into its actual number, we're going to make it smaller. That's what that minus sign tells me. This is positive, so that tells me when we put it back into its regular number, we're going to make it bigger. But here's the secret, you guys, for these problems. We don't have to put it back into its regular number shape, standard form. We're going to leave it in scientific notation form. We're just going to multiply. So here's step 1. Multiply the ones place numbers. By that I mean the 4 and the 2, right? Because those are the numbers we fixed, so they're just in their ones place. 4 times 2 equals, say it with me, 8. That's right, I heard you. Step 2. Add the exponents. 5 plus -2 equals 3. And that's a positive 3. I'm going to be really clear on that. I'm not adding that. Here, let's do this. Let's do this boxcar thing, right? 5, positive 5, and -2 are the two numbers we're combining. And that's positive 3. Now, step 3, easiest one of all, rewrite. So now we take 8 times 10 to the 3rd. See how we use those two pieces of information? The times 10 always stays the same. This is the right answer. Do you feel happy? I do. Okay, I'm not going to write these steps out every time, but we'll do them every time. Example 76.2. Ready? Whoops, that doesn't need to be up there. That's crazy. Okay, John shows these slightly differently. I don't think it's necessarily to show I don't like his steps. What I will remind you is that in these problems, this one too, everything's being multiplied. 3 times 10 to the 8th times 3 times 10 to the 8th. So when we multiply the numbers together, we're just taking those parts and multiplying them. And then when we add the exponents, that's how we're multiplying the two 10s together. We're going to talk more about that rule, but when you're multiplying numbers that match, we call them matching bases, and they have exponents on them, you can just add the exponents. So that's how we multiply the 10s. All right, I don't want to drag you down in the theory. I just want to teach you the practical steps. We're going to be doing this for so long that we'll get to the theory later. All right, we're going to follow our 2 steps. The first thing we do is multiply the numbers in the ones place. That's 9. And we know it's going to be times 10 to the something, and we add the 8 and the 3, and that gives us 11. Oh my gosh. So easy and so fun, right? So fun. You guys are going to throw your gaming systems out the windows, and you're never going to look at YouTube again. Well, except for my channel, of course. It's your favorite. I know it's your favorite. Because this is just more fun than you could ever imagine. Okay, now I'm going to throw you one little curveball. Don't worry, it's not bad. Okay, so it looks kind of the same. Oh wait, what's this? John puts a decimal in there. What a drama king he is. But that's okay, that's not going to blow our minds. All right, so 4 times 10 to the minus 9 times 6.2 times 10 to the 4th. Again, everything's being multiplied, so we can change the order of what we want to multiply. That's not a problem at all. So the first thing we'll do, step 1, is we'll multiply the ones place numbers. So it's 4 times 6.2. And that 4 times 6.2 equals 24.8, right? Then that's going to be times 10 to the minus 9 plus 4. I'm just writing that out all fancy. That would be negative 5, right? Okay, and it seems like, oh wait. Minus 6, oh, I copied it wrong. Let me fix it. This is minus 6. Okay, so it's minus 6 plus 4, and that should be minus 2. Sorry, my bad, I copied it wrong. That is my Achilles heel, you guys. That's almost always what happens when I get numbers wrong. But this looks really good, except you know what's wrong? Look at our number where the biggest digit is just in the ones place. That's not true, is it? We have to fix this number and rewrite it one more time before we're done. So what we have to do is first look at this. This is just like what we did in the previous lesson. First, we have to fix this. We have to move this decimal right there, right? That's where we want it. So it will become 2.48 times 10. Let's see. We want to make this number actually get bigger, so it's a positive 1, right? When this number in scientific notation gets moved back into standard form, we want it to be 24, not 2. That means we want the decimal to move in such a way that it makes this number greater. All right, but now we have to combine it with that, right? So now we combine those two, and we get for our final answer, I'm going to write it here, 2.48. Okay, that's the way we want it to look with the digit, the decimal lined up so that we just have 1 in the ones place. And then this we add, right? So it's times 10 to the minus 1. 1 minus 2 is minus 1. This is our final answer. Oh my gosh, look how smart you must be to understand what I'm doing. Look how complicated. Show that to your younger siblings and they'll cry. I'm sure they will. They'll be frightened. It's like a monster hiding under the bed or waiting in the closet. They're going to be terrified of that problem. And you're like, you guys, that's really easy. I can do these in my sleep. Okay. And that is the end of this lesson. So if you'd like to take a nap and think about scientific notation problems, it's fine with me. Go ahead and rest. You've worked hard. Do I have anything to say to you about the review problem? No. I'll see you on the interwebs. Bye.